Okay, so today we're going to start looking at right triangles and the Pythagorean theorem. Now where this comes from is way back when Pythagoras was looking at right triangles and he was trying to figure out, well, if I have a right triangle like this one, how do I find the length of that based on the first two legs where my right angle is? And they started to say, well, if I look at the areas of squares that these make, I start to see a pattern here. So what we're going to do is we're going to kind of investigate that pattern and see if we can figure out what's going on. So the first thing I notice is that this triangle has a side length, if I'm starting on the far left, has a side length of 4 and this side length of 3. Now we can see how long this is, but I want to look at the areas of my squares. So if I want to find the area of this square, 4 by 4 has an area of 16. And a 3 by 3 has an area of 9. So let's come down to our table. In the area of my first square, I'm going to call my side square my first square, is 9. In the area of my second square is 16. Well, let's find the area of the third square. We know it's a 5 by 5, so that has an area of 25. Now, when he looked at this, he said, wait a second, there's a relationship here. There's something that I can see. So I want you to take a second and look at these and see if we can see what's going on. Not going to say it yet, but I'm going to do the second one here, this middle triangle, and see if we can pick up on it. So again, we have to look at our side lengths. First, I have a 1, 2, 3, 4, 5. So this is a 5 by 5 square. By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a 5 and a 12 by 12. So if I'm looking at areas here, my 5 by 5 is going to have an area of 25. My 12 by 12 will have an area of 144. So here are my first two squares, a 25 and a 144. Now look at this for a second. See what happened on the first one. See if you can figure out what the second one's going to be before we go and actually count it out. So let's look if I'm counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this has a length of 13. And this then is 13 by 13 square with a length of 169. Now, take a look. Have you seen the pattern yet? Do you see what's going on? Well, if you haven't, let's take a look. What happens when I get 9 plus 16? It equals 25. What happens if I get 25 plus 144? Interesting. It equals 169. Let's see if it's the same thing on our third one over here. So I have a side length of 1, 2, 3, 4, 5, 6 on the bottom. So a 6 by 6. 1, 2, 3, 4, 5, 6, 7, 8 on the side for an 8 by 8. So let's find those areas. I'd have an area of 36 on the bottom and 64 on the top. So of my 64 and 36. So using that formula, let's see if I can go ahead and figure out what is my area going to be before I even do anything. So the first two, we added them together to get the third. Well, let's try it. 64 plus 36. That's going to give me 4 and 6 is 10. 6 and 3 is 9 plus 1 is 100. And let's see if that actually holds true. So let's go. I have finding my last side. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have a 10 by 10, which sure enough is 100. So what Pythagoras found out is that if you take the area of a square 1, which is one of my legs, the legs are the angles that make up the 90-degree angle, add it to another leg, then you're going to get what's called the hypotenuse. And the hypotenuse is the longest diagonal side on a right angle. Okay? So there's a little bit of how we're kind of starting to build the Pythagorean theorem formula by looking at how two areas of my legs on the triangle, squares based off of those legs, equal a square based on the hypotenuse.